All right, so we are on to the second module of this course, which is DC analysis. Basically, we're going to be analyzing circuits, and we're going to be looking at the basics, basically some of the easier methods to solve some of the easier circuits, and go through a quick outline of what we're going to cover in this video series. Again, it's going to be broken up into several smaller videos, starting with just looking at circuits with more elements. Oop, I didn't mean to scratch that out. Circuits with more elements. Basically, the first, previously we looked at circuits that had a single source and a single resistor, which are some of the most simple circuits you'll probably ever see. We're going to be adding some resistors, maybe a couple more sources from now on, and looking at some bigger circuits. Then we're going to look at Kirchhoff's laws, which are two of the very fundamental laws of circuits that also help us with circuit analysis, and they're fundamental to solving any circuit, DC, AC, really all the way through any circuits that you look at. You're going to be using Kirchhoff's laws. After that, we're going to look at equivalent resistances. So up to this point, we've only seen a single resistance, but when we add more resistances, we can sort of combine those resistors into series combinations and parallel combinations to make the circuit easier to solve. And then lastly, we're going to go into dependent sources. Again, I scratched it out. Dependent sources, which are a new type of element that we haven't seen yet, and we'll talk more about those when we get there. And there are four types of those. Basically, voltage-controlled sources. There's a voltage-controlled current and a voltage source. And then there are current-controlled current and voltage sources. All right. Without any delay, I'm going to go right into circuits with more elements. And there's nothing new to learn here. I'm just going to go ahead and solve an example right off the bat. So let's go ahead and draw a circuit that has a current source. And let's just say I have a couple of resistors connected, just like this. And I'm going to put my ground right here. And let's say this is a 100 ohm resistor, and let's say that this is a 300 ohm resistor. And let's say that I have, 20 milliamps current flowing in this circuit. And I want to solve for VA and VB, okay? So again, my current, obviously the direction is given by the current source. That current is going to flow all the way through my circuit in the clockwise direction. And so I can go ahead and look at this resistor by resistor if I really want to, and I can determine the current I that flows in my circuit quite easily by using Ohm's law. And of course, this, again, let's go ahead and break this up into the nodes that are present in my circuit. I think it's a good practice to really make sure we know what nodes we're working with and what node voltages we know to begin with. And I think that makes the analysis process quite a bit easier. So the first node is the node VA. I highlight that in yellow. The second node is the node VB. I highlight that in pink. And then the last node is my ground node, and I'll highlight that in green. And so voltages that we don't know, obviously we don't know VA and we don't know VB, but we do know this voltage because it's ground is 0 volts, okay? And we know if we have, basically, if I could kind of, let me take my laser pointer, if I could extract this part of the circuit and kind of just pull it out, what I'm looking at is quite simply 0 volts on the bottom of my 300 ohm resistor, VB on the top of my 0 ohm resistor, or sorry, my 300 ohm resistor, and then I know that I have the current I flowing through it, which is 20 milliamps given by the current source, right? Because that same current's going to flow through my entire loop here. Okay? And so given that I know this, I can go ahead and solve using Ohm's law. I know that V is equal to I times R. Of course, my V is going to be the difference in voltage across my resistor, which would be VB minus 0, or just VB in this case. So I can write VB is equal to I times R, which is 20 milliamps multiplied by, I'm going to go ahead and write it as 0.3 kilo ohms, which is the same thing as 300 ohms, but just so that it makes the math that much easier. Milli and the K cancel, and I'm left with VB equals 20 times 0.3, or is that 6? 20 times 3 would be 60, so it's got to be 6, right? 6 volts at VB. All right, so I know VB, and now I can use the exact same process to solve for VA, right? I have a resistor. Again, I'm going to kind of take this piece of the circuit and extract it and draw it down here. I have that resistor, I have VA. Now I know VB is 6 volts, and I have a 100 ohm resistor here. And again, I know my current is 20 milliamps, all right? And so following the exact same process, let me go ahead and create some space for myself here. I'm going to just move everything. Move that up, move this up. And then I'll give myself a little bit of room to work here. So I can say, again, VA minus 6 volts. Again, that's the difference, the voltage drop across my resistor. I can call that the voltage across R1, and if we want, we could have called this the voltage across R2. Voltage across R1, VA minus 6 volts, again, is equal to I times R. So we know already that I times R is 20 milliamps times, I'll write it as 0.1 kilo ohms in this case, right? And so the milli and the K cancel. I get that VA minus 6 volts is equal to 2 volts. Thus, I can add 6 volts to both sides, and I get that VA is equal to 8 volts. Okay, so that's an example of how I would go ahead and solve a circuit that has, you know, 2 resistors connected as such with a current source, just by using Ohm's law at different points in the circuit. I can always use Ohm's law. I always want to start by writing down my node voltages, and then determining, based on, you know, the unknowns that I have, what can I solve for. In this case, I see I have 0 volts here to start, and I can go ahead from there and solve for VB. Then once I have VB, I can go ahead and solve for VA. All right, I'm going to stop this video here, and in the next video, I'll do another example.